Okay, hello everybody. I'm Alberto, digital fabricator designer in OpenDot. OpenDot, for those who still don't know, was founded in 2014 by Dot, a multidisciplinary studio that mainly deals with interaction design and UX design for museum and exhibition. OpenDot is a fab lab, research and open innovation hub born from the need of Dot to create a place for rapid prototyping, research, and experimentation in support of its work and for the community. We like to have creative and enterprising people around us, and we like it even more if our users have no ideas, they don't know how to archive, and thanks to the support and the skill of the community, they manage to get the product. To do that, we have tools like milling machine, 3D printers, and laser cut for prototyping and manufacturing. All of us have different skills, and if someone doesn't know something, surely there will be another one of us who will be able to help you. In addition to the summer school, we organize free courses for basic machine training every week and advanced courses on specific topics once a month. Today I'm the teacher, but I see there are designer, architects, researchers, neuroscientists among you. And these are moments of sharing. And I'm sure that from this lesson, from your question and your comments, we will learn a lot. OpenDot offers advice to companies, foundation, university, public and private entities. We develop project, path and training programs. Among these, we developed the Co-Design Manifesto following the long collaboration with the TOG Foundation that has listed since 2015. During the co-design process, the knowledge of designers, therapists, and people with needs are united for the sole purpose to achieving unique pieces designed for the individual and at affordable prices. Thanks to the digital fabrication, without neglecting the aesthetic. We want to carry on the concept of design for each. Inside the Fab Lab, we have the opportunity to prototype these devices in different sizes and different materials, from very small objects with the 3D printers, for example, to very large objects with the CNC milling machine, such as Lorenzo's bike with a completely wooden structure, custom designed, and a very important thing is that the same project can be easily adapted on other children because the whole project is parametric. And this is one of the projects born from the collaboration with the TOG Foundation. I must specify that all the devices we realized with the TOG Foundation have been designed with the direct support of the therapist and are not medical devices. So don't think about to scan yourself, make your own bone implants and put it somewhere inside your body. We explain you how tools works and how digital fabrication can help in the field of health and care, helping therapists, doctors, nurses, surgeons, and developing their ideas to let them work easily. Okay, today's lesson will be based on the relationship between surgery and 3D modeling, and how there is an increasing need to bring these two worlds closer. As I said before, in a fab lab, there is the possibility to prototyping almost everything. The tools to do this are many as the skill of those who work there. I will show you how to get 3D model from medical images that can be printed. 3D printing and surgery are spreading a lot, especially in England, where there are companies specialized in 3D printing and for medical use. But how can 3D printing help in a hospital? An ancient insight into the pathology. By holding a replica in your hand and having a true 360 view, you can get a full view of the true anatomy in context. So if you hold your, I don't know, your organ or your bone, and then the surgeon or your, I don't know, the expert can show you which is your disease, which are the procedures that you want to take, and so on. Can reduce theater time. And on average, those who use 3D model to study report a saving of 36 minutes of surgery, with some cases showing more than 5 hours saved. So in this case, planning, studying the pathology can help to choose the right way to less stress the body of the patient and to do a faster operation. Can improve the patient communication. Patient experience and consent are increased by seeing and holding models of their anatomy, aiding in consent discussion. Preoperative training and simulation, educating and training new physicians, especially when dealing with complex pathological conditions. Specifically, what we can do. Patient-specific model that can help study the case and show the patient what will happen to them and helping them understand. In this way, the patient is more relaxed, and it will be easier to have a consent to adopt alternative procedures. Use of 3D printing is being explored for planning, radiological, and surgical intervention in medibody system. Using a 3D printed model for preparation has been reported to allow successfully performance of complex surgical operation. 3D models for education in a digital format can travel everywhere, all around the world, accelerating the spread of new discoveries and allowing everyone to observe and practice recent cases. Specific bone implants. On the patient problem can be created very accurate and perfectly follow the shape of the bones. In this field, there is a lot of research, especially on the material. It's very easy to create bone implants by slicer by computer from medical images, because we are symmetric and we can mirror the part that there is no more. Finally, drilling templates can be created to perfectly fit on the organ or bone of a specific patient. reducing the risk of further damage and the timing of operation. Or simply allow those who cannot to see things they can only see with their hands. For example, this doctor has printed the scans of the unborn fetus to show it to the blind mother. And I have to tell you that I see people who do not have blindness problem who have them printed anyway and use as furnishing. It's just a little bit creepy, in my opinion. So, oops. Going a little further in the technical field, the input that we will use to archive all these things are medical images, such as magnetic resonance imaging and computer tomography. There are other human body scanning techniques, but they are more invasive and expensive than MRI or CT scan. Furthermore, MRI and CT scan are easier to find. You can find a lot of data set around on the internet. So you can download the data set from every part of the body. After I will send you the link to a website that I found where there are thousands of data sets. With both scanning techniques, we have the possibility to obtain slices of our body parallel to the three planes: axial, sagittal, and coronal plane. The big difference is that CTs use X-rays and are used to check bones, tumors, or internal bleeding. While MRIs use radio waves and are mainly used to inspect soft tissues such as heart, brain, and the joints. The images are made parallel to the three planes at a regular distance. By putting them together, crossing all the scan, we obtain cubes. Something like that. Imagine that the blue lines are the scans, the slice, the output. And sorry, they bring me the coffee. The volumes and between the slice, we obtain the cubes. These cubes are called voxels. And the volume of the voxel is between all the slices. The voxels are like the pixels, but three-dimensional. The voxel can give us two types of output. The volume rendering allows us to have an immediate output of the volume that was scanned, and applying different filters can discriminate one tissue over another. With the volume rendering, we obtain a volume that cannot be edited or exported. It only serves to have a quick and three-dimensional return of the scans. So if you want to have a quick view of your scan, you can easily use volume rendering. Now I'll show you where it is in Slicer. Surface rendering, on the other hand, must be realized, reconstructed. And that's what we will do thanks to Slicer. The volume obtained, which we will no longer call volume but mesh, is editable and exportable and printable. All points on its surface, are therefore defined by precise coordinates. Okay. Nerdy note: the meshes are made up of voxel, as I said before. In order to obtain a soft surface, the cubes are cutted following an algorithm called marching cube. This algorithm, as you can see, cuts the cubes to get as close as possible to the shape to obtain a smooth surface. If we look at the picture, we see in the picture below, is more clear. We see on the left a sphere before applying the algorithm, and on the left after the algorithm. As you can see, we have on the left all these steps made by all the voxels, and after the marching cubes, we see the same steps, the faces in the same position of the step, but we have a smooth surface. It took me about a week to figure out how this algorithm works. Here I give you the link to Wikipedia page. Take your time if you want to understand this algorithm and calmly try to understand how it works. Okay, now we can move to Slicer. Okay, I hope you see the tutorial with the basic tools for manual segmentation. If you don't see, don't worry, because we can see going through other tools how the basic tools works. Today, I will explain other functions to perform segmentation more quickly using other tools. I show you how to do less work and a tool for semi-automatic segmentation. So let's open a sample data. Try to use CTA cardio. We use this data set because are made for exercise, are simply to use. All the slices are aligned. There is a good contrast, good quality, good resolution of the images, so are easily to use. Can happen that some images you get from your scan could be not so detailed or defined. This is happened because the resolution, the surgery look at specific disease when scan you, so they focus the attention on a specific part of your body. Okay, the first tool, we use today is called Island. So let's move to segment editor. Check here this drop-down menu that we are using the right dataset, and add a layer. Before using this tool, Island, we have to start segmenting. We have to select a specific zone of the scan. Let's focus now on the aorta. Today we're gonna try to make a multi-part segmentation. So we're gonna do a different layer for each organ, such as liver, kidney, aorta, the heart, maybe the bones. Let's see how much things we can do with different tools. Okay, now let's start from the aorta. Rename it. Change color, because I like red aorta. Okay. And with the threshold, let's try to adjust the threshold in order to have the selection of the aorta separate from the other part of the, in this case, of the spine. It's not easy. Maybe you need different tries, and I show you how to do this faster. So let's try adjusting. Here is looks like it's quite good, but let's scroll through the slices and check if it's all good. Oh no, sorry. Sorry. Close this sheen, because it's much easier and faster with another data set. Sorry. And let's go back to download the sample data and CTA abdomen panoramics. Because the scan is more detailed and we can select much easier the different part, the different organ. Okay, it's much better. So let's go back to segment editor, segment aorta. Red color. Okay, adjust brightness and contrast. Okay, by adjusting brightness and contrast with the left click of the mouse, move up and down on the slice. Up and down for luminosity, and left to right, brightness, left to right for the contrast. So this is quite good. In threshold, move the handle. Okay. I don't like it, so move the handle to the left. Okay. It's quite good. Okay. Click apply when you've done. And show 3D in the module panel to show see our segmentation in the 3D space. So there it is. We have segmented everything. There is now the kidney, the pulmon, but we have all the bones, the heart. It seems that is pretty good detailed. Now with the tool island, we'll check if the volume, the mesh of the aorta is connected to something else. And we see all the operation we can do with the island. Okay, with the island, we can do different operation to, I don't know, clean the 3D space, erasing all these little mesh, moving the mesh from a layer to another one, remove, keep only the largest island. So with this tool, we'll keep only the biggest mesh. So if we hit apply, he start computing and he keep only the bones. But we want to keep the aorta. So undo. We can remove a small island. So like this, he's going to erase all this piece. And he didn't delete this one because here we have a minimum size of the voxel to erase. If we go down with this number, if we digit a lower number like 100, right? And hit apply. Oh, you don't want to erase it. Anyway, I don't know why. Okay, let's keep going. Split island to segment with this operation. A slicer will create one segmentation, one layer for each separated volume. With this operation, there is the risk to do thousands of segmentation of layer. So use this option only when you're sure that you have maybe 10 segmentation, 10 volumes, separated volumes to separate easily with just one click. You can say to keep selected island. So by clicking in the slice, by clicking the aorta, automatically delete everything, but not the aorta. In the same way, remove selected island. And the option that I prefer, that is more clear, is add selected island. To use this one, we have to create another one segmentation. Maybe we can call it erase. Keeping it selected, add selected island, and click in the slices the segmentation we want to erase. We want to move to another layer. We can also call it, for example, bones. And choose to move this segmentation in this layer. As you see, we move all these volumes in the layer bones, in the segmentation bones. So with at the selected island, we have more control on the operation. But like a split island to segment, but in my opinion, it's better. So I lost myself. Okay. Let's keep only the aorta. So remove this one, remove the bones, keep selected island, and here we have our aorta. That is pretty good detailed, and in few minutes we have do a perfect segmentation. Okay. Now we can try another tools, but before I want to show you how to segment a specific area in our data. In this case, the case I've shown you before, we segment the whole data set, getting a lot of information using a lot of computing memories, and in some data set it can took a very long time for computing everything. If we want to work on just one part of our data set, we can go back, hide the aorta segmentation. We can go back to volume rendering here in the drop-down menu. Oh, I didn't explain you the volume rendering. Volume rendering, as I said before, is just for visualization. For getting volume rendering, go in the module volume rendering, check that the right dataset is selected, and hit this little eye icon. And immediately in the 3D space, there is our volume. Here we have many presets that read the information inside the data set and translating it in a volume. With this handle, we can adjust the threshold, so we can hide or see different tissues. So, as I said before, that's it. This is the volume rendering. Very fast, very useful. If we want to give a quick look at the scan, it's pretty much detailed. We can easily take a screenshot with this tool on the toolbar. And I think it's the most used in the hospital before doing an operation or for viewing the scan. Okay, let's go back and select the part that interests us. Let's try to segment the 2 kidneys. So try let's find a preset that fit us, that let us see the kidneys. This is quite good. Oh, another things you can do with the volume rendering. Going back to segment editor, you can view the aorta and check if they fit together. And here, and as you can see, we do a quite good job, except some little part. But by spending more time on the selection of the slice, we can obtain a very precise segmentation. Okay, now we're going to crop the volume, keeping only the 2 kidneys. To do that, we have to enable crop and display ROI. And now we have to fit this box with this handle for the kidney. So now in real time we can see that everything is outside the box disappear. So don't mind to do too much precise. Try to remove the more volume as possible. This looks quite good. Okay, now we have only our kidneys, but we don't yet crop this area. To do that, go to the all module menu and find crop volume. Here we can simply hit apply, and now we have created another volume with only this information. We can rename this volume to have everything ordered. So in output volume, can hit on rename current volume and call it kidney. Okay, now going back to volume rendering, we see that here appear another volume. To see only this volume, now we are in the panoramics, in the big volume with all the information. You have to uncheck the little eye, so hide the master volume, and it's kidney. Open it. And here we have only our kidney. Automatically, we have cropped also the slice. And again, here we have our two dataset. Panoramics with everything, and only kidney here. I don't do a very important things before start working. That is linking all the slice or the orthogonal view. So click the chain button. So now if I change the volume, wait, why? Will change in every slice. Okay, now focus on the kidneys. Hide the volume rendering. And go back to the our segment editor. So for segmenting the two kidneys, now we can try to do two different meshes, one for the left kidney and one for the right kidney in a single operation. To do that, we can use Grow from Seed tool. That is this one. To use that tools, we need two or more segmentation, two or more layers. So let's create two segmentation and call it kidney R and kidney. Okay. And now we need another one segmentation for the background, for all the part that don't interest us. Now I'll show you why. So call that the segmentation background. Change the color. Beautiful bright green. Okay. Now let's start selecting the kidneys and the background. For using Grow from Seeds, we don't need to be precise. So to do that, we can select right kidney, paintbrush, and start to selecting the kidney. On the same slice, but you don't have to go on the same slice. We select the seeds. Now we are giving to the software, to this algorithm, the seeds. So we have selected the seeds of the right kidney. Now we give some seeds for the background. Do very, very, very rough move. Remember to give seeds also to the last layer. So in the end, is going to create a box with and the limit of that box are the selected slice. Okay, let's keep going to select other parts. So here is the background. Select kidney and then draw on the kidney. Maybe you can change the diameter to be more precise. In this way, the algorithm take the voxels with the same parameters and will match each other. So keep going. Okay, now appears the second kidney. So background. So do a very, very rough segmentation on kidney. I'm choosing to select only the lighter part of the kidney because the kidney have all these holes, very beautiful holes. And now we're going to give the seeds to the other kidney. Now you can do this operation on every slice you want. Okay, background, left to kidney. And then right kidney. You also can do that on the other slice. Maybe you can do one slice here on the sagittal, one on the axial, one on the coronal. You can draw everywhere you want. Go up, background. Left. Okay. And finally, the last slice, only background. Okay. An important thing to check is here in the module panel. In the lower zone, we have a masking tab where we can say which is the editable area and which segmentation we can overwrite. Editable area is everywhere. We don't want to have limits. Overwrite other segment. We select only visible segment because if we don't do that, our segmentation will affect the aorta segmentation. Sorry. Okay. Now that we have selected on some layer our two kidneys and the background, let's go back to the tool Grow from Seeds. and simply click initialize. And now he starts to match all the voxel with the same property. As you see, now we have segmented the background in green, left kidney, and the right kidney. Very fast, very precise. We can even do more precise because now we don't have a mesh, so we can edit the segmentation. If you click on show 3D, you have a preview of the two kidneys, so we can check if it's all right. So I see that here the surface is not beautiful. Here there is a lot of chaos. So how to modify the segmentation? Simply, as we do before, by clicking on the segmentation here on the left and using the basic tools like paintbrush, draw, and erase. Maybe you can use only paintbrush and erase. So select, we see that the left kidney, that in real is the right kidney, because this view is seen by the bottom. Anyway, so let's correct this shape. Let's check the shape. So click on kidney left, and let's try scrolling through the slices. We can check the shape of the kidney with paintbrush tool. If we click on a part that interests us, we give to the algorithm more seeds. So as you can see, I just click on these voxels, and he computing and find other voxel that seems the selection I've just done. So for refining this, we can click on background, again paintbrush tool, and paint. It's very easy. So you can keep going to refine the shape by jumping from a layer to another. So I am destroying everything. So the more information we give to the algorithm, the more will be precise. So as you said,
non so se vuoi fare un momento di domande, cose.
Sì, adesso faccio.
E pausa poi, o prima pausa e poi domande.
So now background, paint. We can check here where we are in the 3D space. If you look, if you see, if I move the paintbrush, the mouse on the slice, we see a little cylinder that is our brush. So we can point the the areas, the seeds that we don't want to be a part of our segmentation. So we just click here, and immediately will be updated in the 3D space. Okay, this one, I don't like it. Okay. Okay. So going up. Here it is. Okay, let's. Oh no. Easy. Also, there is quite good. So we can continue near the aorta, giving more seeds. Ooh. It's too much. Because this happened because before we give seeds like this one, that this is background. So, and in another slice on the same voxels, we say this is the kidney. So he didn't know which voxel takes for background and for the kidney. So this he computed this shape. So let's undo using erase. Okay. Erase here. Oh. Remember to jump from layer to another. No. And change the tool. Okay. Background. Okay, looks good. Let's check the other one kidney. So we go in the lower slice. Here we have an open surface. And we can close it. Let's try with this kidney to remove also these areas. So background and add seeds. Let's add also this one. Maybe it's too much, but as you can see, it's to show you how this tool works. In a very easily way, we can segment every organ. Okay. We can do the same things we are doing for the two kidneys to do the inner and the outer part of the kidney. For example, we can apply these tools for very different operation. Okay, now let's check the outer space, the surface, sorry. Looks good. Okay. As before, I don't want to try to select the vessels that goes to the aorta. Okay. When you have done with the segmentation, let's go back to grow from seeds tool. Check to overwrite only visible segments and hit apply. Bang. Now we have the segmentation of the two kidneys and the background. We can remove this layer. So now we have the two kidneys and our aorta. Oh, these look great. This is a very beautiful match. And this is horrible. But spending more time, you can use, you can obtain the same on all the organs. So now, if you want to do me some question or just show what you have done with the slicer, you can take some time to show your work, asking everything you want. I'm really interested in some of your application for the software. In OpenDot, we can use this mesh for we can use just for 3D printing. Use that as a patient-specific model, or for create a 3D model for education. As I said before, we can't do bone implants because we don't have the right material, and we're just a fab lab. We can't create something that will goes in the body of somebody. Even we can't do drilling templates or surgical guide. Here in OpenDot, unfortunately, we have two fused deposition material and one SLS printer. So the range of the material that we can use, it's very little. So we can just prototype, we can just develop a project, and then allows you to bring your project to maybe a service that is specialized in medical 3D models.
What kind of printer that you should use to print this model? Normally, you use a soft material in order to cut, or what is the purpose?
No, allora, for the 3D printing, we can use only hard material. We have a flex material for the FDM, but it's very hard to use. If you want to do something soft, we can try to create something with molding and casting, for example. Enrico Bassi next week will do a lesson on which he will explain you how to make molding and casting for medical use.
Now, maybe I explain me worse. I mean, not in Fab Lab, but I mean in the world, people that use this slicer and make 3D model after they print that model in solid material, or what? Which kind of if you put inside the body, maybe they make in Titan. But if you use in other way, which, for example, for study the model before, they just print hard material to see in your hand, or how you use this specific model in a hospital or something like that?
Sorry, I can answer you for Roberto here. There are a lot of 3D printing technology that can be used in this kind of situation. There is a lot of 3D printers like from HP and Stratasys that can work with different materials. So you have a different resin that are printed like an inkjet 3D printer, and those can use both flexible and hard material together. So they can make a mix between those, and also they can print different color together. So the model you have seen on the presentation of Alberto, the one with the like the head in section with different colors, it's printed all together in one batch. So it's just an inkjet printer, but they use resin. If you want to obtain a really flexible material that you can work with, so for example, the lesson of Enrico will be about models that are used for training for surgery. Actually, it's not easy to use 3D printers because it's the softness of the material 3D printed. It's not enough usually to be that flexible for be actually similar to the skin or similar to other part of the body. So we tend to use a bit more of a maker way to make that kind of process. For example, there is a user of the Fab Lab, which is Nicola Norman. It's a designer here in Milan that is becoming more specialized in make training kit for a surgeon. So it's making a lot of molds, 3D printing molds for making cast later. So it's mixing a lot of technique to get that result. And it's making like full body with inside transparent, with inside all the veins, with system pipes, whatever, to make different kind of fake operation to train the surgeon. So you have a full body, and then in some part you have like a small patch made similar to skin, and then you can open the skin, go inside, you see that organ, and they try to reach that from that opening and so on. But it's a really mixed technique in that situation.
Okay, thank you.
Okay, another question from Martina. She asked, how do you understand between light gray and dark, which are the part to erase or not? You meaning in grow from seeds?
Sì, and also before when you were just doing some paint, some line. So I will do this. So they were not so precise. And so I was not understanding why you were doing that. So you were line around in gray. And then you were saying, okay, in the kidney, maybe a piece here is enough, a piece here. So that so in the process before grow to slide. No, grow to
Seeds.
You were trying to remove, to erase the part of the kidney, for example, that to clean that.
How can I say? Let's go back to slicer. Okay. How can I show you?
So when was all the background green and kidney? And for example, also in a kidney there were the inside. For me, I was thinking just the limits.
Okay, and it was full inside.
Yeah, you were with the.
So the seeds grows with the voxel with the same parameters. So if you click, for example, try to with the lung. Okay, try to do another one segmentation. So, DG. Okay, change color. So we can, for selecting the lung, we can or do another segmentation. The seeds can be just a little click, even if with zoom in, could be a very, very little voxel.
Okay,
And,
so it's so little. What you do with these 2 points, or just with some line?
we identify the two, in this case, the two lung.
Okay, yeah, okay.
So when the algorithm works, we'll find all the voxels with the same parameters of this one.
Okay.
And this one. Maybe in the outer part of the body, there are voxels with the same parameters, but here we have the limit. Also, we can give the limit using background by clicking on the white voxel and outside.
Okay. These were the line that were asking me for. I was asking before, because I were.
The last one.
Yeah. Okay. Now it's clear, because we're so rough, and I was saying, what are they? Why?
Yeah, this is the beautiful thing. So because you don't have to be precise, you just select the voxel you want to put in one layer, in one segmentation, or in another one.
Okay, thank you.
Okay. Okay, Maria asks, how does it work with the X-ray files sources? X-ray files are just, it's like a photo. X-rays didn't have any information. It's just as like have just a slice of the data set that we have used. So we can't extract. The X-rays are also is like having all the slice in one picture, in one data set. So we can't extract a volume or a mesh.
Okay. Can you also import the real ones X-ray, just like saying my X-ray I did yesterday?
Yeah, I think so. I didn't try yet, but I think so. In Slicer, you can also import other scanning, other types like PET. That is a scan with a contrast liquid.
Okay.
For viewing, I think, if I remember right, it's used to see the vessels, arteries, and so on, or also the brain. But I'm not a doctor, so. Okay.
Maybe usually it's easier to import 3D scanning.
Yeah.
Rather than X-ray files.
Yeah.
Okay.
The best is CT or MRI.
Okay.
CT scan are easier to edit, to build volume. because there is more contrast between bones and the organs. Okay. In MRIs, are much clearer the muscles, the vessels, and it's much difficult. It's possible. It takes a long time to extract a volume or a surface. So now I'm going to show you another one basic tool for selecting on the slice, and maybe other two tools for refining the volume, and next how to export for Mesh Mixer and Fusion 360. So now there are one basic tools that we can use is level tracing. That is something like paint or draw. But with this tool, you can select a specific area with the same properties on only one slice. So you can use it for selecting the segmentation for the grow from seeds, for example. If you have a large area with the same properties like this one, or I don't know, for the bones that are totally white. So this is another tool you can use for selecting the segmentation.
You can combine these with seeds?
Yeah. Because seeds, it's an algorithm that use 2 or more layers. So you can use every tools you want to select the seeds. So if we keep going with the lung and level tracing, we have selected, where are? No, it's too much slow. Here is our selection. Let's do another one. So we can combine with paint. I don't know. Tick, tack. Background maybe with the level tracing. No, with the background, it's not a good tools to select the underground because it's going to. Oh God. What happened? Why? Okay. Why don't select anything? Okay. We can select the background because we'll do a selection like this that have inside the lung. Maybe trying like this. I didn't try yet. Oh yeah, yes, it's a good tool like this. I never try this workflow, but we can easily try. One like this, one like this. Background again. Maybe taking some bones. So we can segment just 3 layers. So this is the background and the lung, and then going grow from seeds.
Grow from city is just work on the visible layer, or
Yeah.
it's a job of kidney?
No, on all the visible layer, because we are working on this dataset, panoramic cropped,
Okay.
not on kidney.
Okay.
Okay, it's part of the same project of the same scene, but are 2 different volume and 2 different dataset.
Okay.
So, and here we have our the preview of our lung. So very quickly, pretty much detailed. Then apply. Sure, the more seeds we select, the more precise will be the segmentation. But as you can see, we do a great job. Wow. Good job, Alberto. And everything perfectly fits. Okay. Now, one refining tool before exporting and before going in Mesh Mixer or Fusion 360 is smoothing. With smoothing, we can smooth the surface of our mesh. So let's choose only 3D. Select the right segmentation you want to smooth. Let's try with the aorta. And then select the size for the smoothing. Here is 3 millimeter that we can lower it a bit because it's going to with the higher value of kernel size it's going to erase the thin part of the volume of the mesh. So let's try with 1 millimeter. Just one.
Where do you find this?
Here, near scissor and hollow. You don't find it? Okay.
Oh, yeah, okay. Sorry, I say okay, but I don't have a microphone.
And then hit apply. So you have done. We don't see the difference because it's too much little these parameters. So undo. Let's try with the 3. Let's see what happened. So, did you see? We lose. Let's try with undo. We lose a lot of detail, but we feel a lot of holes like this one. Okay. depends on your what you want to do with the volume. This operation is better. It's better to do this operation with the mesh mixer, because you have more control, more parameters to set to maintain the same volume, but reducing the noise, the errors, the holes. So all the refinement process on the mesh is better to do on mesh mixer. Another one tool we can use is Hollow. Also, this one it's interesting to see how it works, but it's better do this operation in other software. So hollow, you can choose to hollow inside the surface, medial surface or outer surface, and we can choose the shell thickness. Again, with this operation, we're going to lose a lot of detail, especially in this this part of the module. So we can use it with the lung. Try with 1 millimeters. And apply. And then we have a hollow volume that is easily printable with 1 millimeter thickness of the shell. We don't lose any detail on the outer surface. So for some project could be useful. Okay.
I have just a question.
Yep.
In my software, I still see the image, and not where are you? Because you see the 3D model, I see I never do a model, but I see. How to say? I think that I saw the image from the 3D image when we was to volume. I still see the volume image. Maybe how to don't show this.
You want to hide the volume rendering?
Yeah.
Okay, so go back to volume rendering.
Yes.
And select the data set you're using, because it will stay visible even if you change the volume, the data set. You keep the visibility. So every time you hit this button, when you don't need no more, you have to hide the volume.
Okay, thank you.
Okay, now let's export and then import to the other software. So let's go back to Segment Editor. Remove this layer. For exporting, the beautiful things of Slicer is that it exports one STL file for each layer. And most beautiful things is that he keep the same origin for all the segmentation. So when you import all the mesh in another software, you can easily assemble it in the right position. I'll show you. For exporting, let's go in segmentation. On the right-hand side of this button, there is a little arrow, and click on export file. Let's choose a destination folder. Create on desktop a new folder. Okay, choose. File format STL, size scale 1, and it exports. As you can see, we have the 4 segmentation we have done in Slicer. Oh, sorry, I'm only on Slicer. Just a moment. Okay. Now you see, okay. As you can see the 4 segmentation we have done in Slicer. STL format. And that's very good things. So now let's open Mesh Mixer. Mesh Mix, Tiziano next time will explain you all the function of Mesh Mixer. Because if I start explaining you also Mesh Mixer, we can finish about tonight. So I'll show you the first steps in Mesh Mixer, how to import and to repair the mesh. So let's drag and drop our segmentation. And this is our aorta. If we want to import the other segmentation, just click, just drag and drop, append, and boom, it's done. Very easy. The same position, same origin. So let's import the kidney. One kidney, the second kidney. And here we have the same situation that we have in Slicer. Let's try to change the shaders so we can our aorta and the 2 kidney, 1 green, 1 purple. It's very easy to use Mesh Mixer in the first steps because very intuitive, big icon. Okay. The first things you have to learn for Mesh Mixer is save every time. Same every time before doing another operation. So, file, save. in the same folder. Okay. First, we can repair or check if the mesh is correct, didn't have holes or any kind of error in the mesh by clicking on Analysis, Inspector. Here we see all the errors that are in the mesh. So maybe are open faces or inverted normals. Could be everything. So let's change the whole fill mode, selecting smooth fill, and click auto repair. Do the same operation on all the mesh. Smooth.
Why you select smooth and not the other?
Because if we say flat fill, if there is a hole, will be filled with planar, with a flat face. If we choose smooth, the software tries to follow the shape of the faces that are near the hole. Okay.
Yes. Yes.
Kidney. Okay. Another thing we can do is to check the dimension. By going in Edit, Transform. And here in the object browser, we have selected kidney, left kidney. And here we have the size in millimeters. So it's 85 millimeters in the Y direction. Seems is real size, I think. I never see a kidney. I never hold a kidney. Probably. No. Probably it's an adult kidney. Okay, so this is a real size model. Here we can scale it for have a preview print with desktop printers to check. I don't know if they fit with the other part of the segmentation before sending to the service or who knows who can print large object. Another things we can do, we can using this tool Mesh Mixer, we can import primitives, maybe by clicking and drop. This you can use for, I don't know, to build bold implants or drilling template. So by modeling the primitive, we can attach to the surface the volume, the mesh, another mesh. Then going in edit, change the dimension with the precise measure. Maybe this could be 10 millimeters, non-uniform. 30 millimeters. And okay. We can move it, we can rotate. And okay, next time Tiziano show you how do operation between the volumes. So in this way we can, we can do Boolean operation between the volumes, between the mesh, to obtain a drilling template, a plug, or something else that fits perfectly on the mesh. And then on the organ or the bones, all the part we want to do a job like this. Okay. Now we can see, we can also import in Fusion 360. So let's open Fusion. We can import, we can use Mesh Mixer just for repairing the meshes and prepare the meshes for 3D printing. But Fusion can be used to create parametric plug or parametric drilling template, and also we can use it to using Millie machine to create a prototype, maybe a heart made milled in the wood. I don't know. So in Fusion 360, to import the mesh we've done, we have to go in the toolbar, insert, and where is insert mesh? Let's go. Okay. Lecture. And here we have our aorta. And these are all the faces. Oh, another things we can do in Mesh Mixer is to reduce the faces, because here we have a very high detailed mesh with a lot tons of faces, so the file will be very, very heavy. Also there, if we import the other part, keep the same origin. Okay.
But also in Fusion, we can repair the mesh, or it's better to pass before in Mesh Mixer and after?
No, it's better in Mesh Mixer because it's easier. The algorithms that repair the mesh are much easier to use.
Okay. And after we save in another STL to import in Fusion.
Yeah. Come faccio a togliere il wireframe? Mi ricordo. I want to remove the wireframe. No. Display settings. Mesh display.
Visual style, forse.
I love you. Okay. And okay, that's all. I think I've explained you how to do the first segmentation with slicer. Oh, it's only 12 o'clock. If you have questions or if you want me to explain other things, maybe there is a question. Subtraction are possible in mesh mixer? Sure. You can do Boolean, subtraction union between different volumes, and I can show you how to do an operation. Okay, I'm on mesh mixer, so let's. Posso importare direttamente qua? Sì. Let's import. Wow. Two volumes. One and the rabbit. Okay. Hide the others. For doing operation in mesh mixer, you have, for example, subtraction. You have to select in the object browser first the volume you want to keep, and then the volume you want that you use to subtract. So we want to keep the rabbit, then select the cube, and then appears here this menu. Click on Boolean difference, and it's done. It's much complicated with two mesh with a lot of faces, because here we have a lot of aiutami. A lot of handle to setting the result of the operation of the difference or the union. Union or difference can also be done in Fusion 360 here. But mesh mixer works better with mesh, and Fusion is better with the surface. There is a big difference between mesh and surface, and you can use all the software. Depends on what you want to do. Other questions?
Can you show how to fix the meshes in Mesh Mixer?
how to fix.
To reduce the meshes.
Ok. Allora, let's delete hide these two. No. Let's select, for example, the kidney. Here, in the right corner, we see the properties of the mesh we are selecting, and we see that we have a lot of verticals and triangles. For reducing the faces, we have to go to select, Control A or Command A for selecting everything. And in Edit, we can hit Reduce, choose Reduce. It's calculating. Now we are saying to reduce by 50% the original body. Before reducing the mesh, it's better to duplicate the segmentation in case of every kind of error. We can go back and start from the original volume. So select, Control A, Edit, Reduce. Don't use the handle to change the reduce percentage, because every step you start calculating the reducing. So you can double click on the number and choose how much reduce the mesh. Maybe 80%. Let's keep a tick on preserve boundaries. It accept. Okay, and now we see that here in the angle, verticals and triangles are very low. In rispetto, sorry, to the other kidney.
Where do you see the number of phase?
In the lower right angle here.
Okay, you select the body and they say about that body.
Yes.
That you
You see, this is the original body, and this is the reduced body.
Okay, thank you.
Okay. Okay. So as you see, we don't lose the original shape. It's quite the same. Maybe we lose some detail, but it looks like quite the same. Okay.
Okay, thank you.
Sorry, in select and after is in which?
Select, Command All.
Yes.
Edit, Reduce, or Shift R.
Okay, thanks.
And that's it. And now I'll show you how to import. So let me find some data set. here. So going back to, let's save before. Save. When you save, you can choose what part of the whole project to save. You can save only the scene, just one segmentation, every segmentation, the annotation, a lot of things you can save. So in the folder, let's go in desktop. Let's do another folder. And save. Okay. Let me check. Okay, and here we have everything. If we want to export another data set, let's do close Shin. Okay. Conventional. And here we have a data set. It's raw. This is raw data. Your surgery or the expert give you this file. You can easily drag and drop in the software. Click OK, and then you have your data set imported. It's very easy to use. So if we go back to volume rendering, select. And now we can start segmenting. Change parameters. Okay. Here we can easily segment the bones. In this folder, I will give you also this data set, so you can start playing with this data set, or you can use the link I sent you before. No. The view in the dataset you import, you have to check to align the views. For aligning the views, before we have to link them, and then click on these two little arrows, and click this button here. It is called the rotate to volume plane. These are aligned, but let me check if I have another data set of an MRI, so I can show you how MRIs are. So, and this is MRI. So take the whole folder of DICOM data and drop it in Slicer. He asks you how you want to load this image. Click OK, and then.
So normally, also when we save before you save and you make a lot of file, if you want to open all the file that we have saved, we have to import all the folder.
Yeah, Yeah, because in this folder, I don't know where, is right. There is something right that with information of with the orientation of all the slides. So it's better drag and drop all the folder in Slicer. So as you can see, I've just imported this data set. This is another one data set that I imported last week. And these are all the volumes inside the data set. So we can check, we can load everything. Okay, discard it. Okay, these are not aligned. And all the data set, all the different scan inside this data set, we can see that here. These are all different type of scan. Oh. So in the MRIs, as I said before, you can see the muscles, I think this is the menisco. And another one series, that one. So as you can see, this is very detailed, and these are not. Maybe this view, the axial view, is made every 0.1, 0.2 millimeters, and these are made every, I don't know, 1 millimeters or 5 millimeters. Depends on what the surgeon want to see. And we have to align every series of slides. And if we go in volume rendering, also there we can see all the series we see before. These 8, always check that these are the same, because if you change here didn't change. So MRIs are more difficult to also in volume rendering. It's difficult to visualize in volume rendering. Also the presets didn't work well. Also adjusting the threshold, and this doesn't work. This is for the preset for the brain. We can just see a little bit the knee. And trying to segmenting MRI is very difficult, because it looks like the gray are quite the same. So it's difficult with the threshold identify just one part. So it needs more work, more tools, and more time to segment the the part you want, you're interested in. But it's possible, you can do. For those who are still there, I want to show you the first attempt with the SLS printer. I print a little vertebra, segmented in, I think, 10 minutes, one of the first segmentation. And this is the result. You see? Yeah. So you can rapidly obtain things like that with an SLS printer. So I'm very proud of my job. And if you want, you can come in our Fab Lab to do these things. It's very fun.
They don't need support SLS?
Yeah, need a lot of support.
Okay.
If you want, I show you SLS print. This is the result of an SLS printer.
It's easy to remove the support of SLS in report of FDM?
Sorry?
It's easy to remove support from SLS, or?
Yeah. It's very easy because are very thin as supports. So yes, are sorry, not SLS, SLA. So you can easily remove without
more easy than FDM.
Sorry?
More easy than FDM.
Yeah. Because they have a little contact point.
Okay.
On the surface of the model. So as you can see here. Okay, and that's it. Bye-bye. Thank you.